Alright, so Algebra 2 Trig Honor students, so this one is the second half of 4.3. So the alternate form of secant and cosecant functions, so y equals secant of quantity bx plus c, or y equals cosecant of bx plus c. Again, the structure, they're pretty much the same, according to that cosine, sine, tangent, and cotangent. And this one is for secant and cosecant. And then the ultimate form, again, as you can see that the capital B right there is being factored in. So y equals k plus a secant of capital B times x minus h. And then for the cosecant, it's pretty much the same form. So just change the function into cosecant. And where b is greater than 0, period, 2 pi over b. Phase shift, it's h. The reason why it's 2 pi again, because that secant and cosecant is based off the graph of cosine and sine. And again, vertical translation, k. And for the scalar, a, again, for secant and cosecant, there's no such thing for the amplitude. Okay, so that's just the scalar. So if a is greater than 1, that means the graph would be stretched vertically. If a is less than 1 but it's greater than 0, that means the graph would be compressed horizontally. Okay, so let's look at that example. So sketch 1 complete cycles of each of the following by first graphing the appropriate sine or cosine curve and then using the reciprocal relationship. Okay, so definitely that would be the easiest strategy to come up with the secant and cosecant graph. So let's find out that all the central elements. So the central element, that means the scalar. So the value of a, which is 1, absolute value of 1, then that's 1. So that's a normal secant curve. And then for the value of b here, it's not shown, so that means 1. And then for the period, so 2 pi over b. So 2 pi over 1, then that'd be 2 pi. And now what else do we know? The value of h. It's negative pi over 4, so pi over 4 unit to the left. And then the value of k, it's not given, so that means 0. And also we can do the one cycle test. So the one cycle test for secant, it's from 0 to 2 pi. So it's the exact same one cycle test as the cosine one. And then x plus pi over 4. Subtract pi over 4 both sides, so we got negative pi over 4. It's less than or equal to x is less than or equal to 2 pi minus pi over 4. Then that would be considered 7 pi over 4. Okay, so let's just make the x-axis and the y-axis. Okay, let's just do that part right there one more time. So from negative pi over 4 to 7 pi over 4. Okay, so it's from here all the way to here. And then the y-axis, the x-axis, and then the 0. Okay, so now the amplitude, so this one, if that's a sine cosine curve, the amplitude would be considered 1. Okay, so based on the scalar, so started with 1 down up here, negative 1 down here. So half of the distance between negative pi over 4, 7 pi over 4, then that would be considered 6 pi over 8, which is 3 pi over 4. Okay, 3 pi over 4. And then half of the distance between 3 pi over 4, 7 pi over 4, 10 pi over 4 divided by 2, 10 pi over 8, which is 5 pi over 4. And then half of the distance between negative pi over 4, 3 pi over 4, and that'll be 2 pi over 8, which is pi over 4. Okay, so started with the basic curve, the parent functions based on the cosine. So that based on cosine, so this one started at negative pi over 4, then that'd be 1. And then over here, then that would be considered 0. Over here, negative 1, 0. And then back to 1. Again, this one is just the reciprocal functions of secant. So it goes this way. And now, excuse me, what happened at the 0 here? At the 0 position, you'll see that it's a vertical asymptote for that secant. So let's just swing the vertical asymptote, dot it, and here's another vertical asymptote because the reciprocals of 0, it's undefined. And then for those, you might be wondering what happened at those max and min for the cosine. So at those points, you'll get the vertices. You'll get the vertices of the parabolas of secant. And then for this secant graph, it's just a normal curve. So there's no stretching, no shrinking for the parabola. So basically this one, we can just make the parabola. So this one is halfway through. And this one down here, just like a normal parabola. No stretching, no shrinking. And this one too, just like a normal parabola. Okay, so that's the one for secant of x plus pi over 4. And now, what about for the other one? So the other one, 1/3 plus cosecant of 3x minus pi over 2. So let me just snip that one. And then I'll put it into the new slide. Okay, so for this one, so we do have y equals, you just rewrite it, so cosecant of, well, for the 3, the value b, you can put it out, so x minus pi over 6, because you take out 3 already, so 3 times pi over 6, that would be pi over 2. And then 1/3, just swap them with that cosecant. So what we got here, so a, it's absolute value of 1, which is 1, and then b is 3. And then the period, 2 pi over 3. And then h is pi over 6. And then for k, it's 1/3. And now let's see what else that we have. The 1 cycle test. So for the 1 cycle test, we do have from 0 to 2 pi. And for those you might be wondering, why do I include that 0 and 2 pi? Just the less than? Well, because that for the parent graph of cosecant, it's 0 and 2 pi. Those are the vertical asymptotes. Okay, so the quantity, so 3 times the quantity of x minus pi over 6. You want to put it here in the middle. And for those you might be wondering, can I put it the original one? Yes, either way is fine. Okay, by the time you solve for this, eventually it's going to be the same thing. So divided by 3 on both sides first. All 3 sides, so we got 0 is less than x minus pi over 6. It's less than 2 pi over 3. And then add pi over 6 for each side. So we do have pi over 6. It's less than x. It's less than, well, let's find out what that is. So 2 pi over 3 plus pi over 6. So we do have 4 pi over 6 plus pi over 6. Then that'd be 5 pi over 6. Yeah, so this one basically gives you the initial positions, the final position, or the starting point and the end point. Okay, so x-axis, y-axis. Okay, right here. So from pi over 6 to 5 pi over 6. So here's pi over 6, and here's all the way through 5 pi over 6. And half of the way in the midpoint here, so this one, it's 6 pi over 6 divided by 2. So it's pi over 2. And then half of the distance right here, so pi over 6, pi over 2, 3 pi over 6, 4 pi over 6 divided by 2. So 2 pi. Okay, so can I do it mentally? Just show the work. So this one is 4 pi over 6 divided by 2 multiplied by 1/2. So we got 2 pi over 6 pi over 3. And then right over here, so pi over 2, 5 pi over 6. So this one's 3 pi over 6 plus 5 pi over 6, 8 pi over 6 divided by 2 times 1/2. So 4 pi over 6, which is 2 pi over 3. So once again, at the initial position, you'll see the vertical asymptote. But before you do that, you want to put in the sine curve here because the reciprocal function. So for sine, you started at pi over 6. Well, this time with the vertical translation, so you got to be very careful. Okay, so started at 0 first, just the sine curve. Again, amplitude is 1 for the sine curve, so it's all the way up here at 1, and then 0, and then -1, and 2 pi over 3, and then back to 0. Again, this one is just a reciprocal function of cosecant, the sine curve. And as you may notice, at the 0, we do have the vertical asymptotes. So for those zeros there, we need to swing the vertical asymptotes. Well, it's not solid, it's supposed to be dotted. Okay, so the first VA, and here's another one. And here's another one. And then with that 1/3, so 1/3 is just the vertical translation. So that means we need to shift those point 1/3 unit up. Well, not the vertical asymptote, but the max and the min. So 1/3 unit. So 1 plus 1/3, so 1 and 1/3. And then down here, -1 plus 1/3, -2/3. So it's 1/3 unit up. Okay, so up here, and then the one down here. Well, because that at those positions, you'll find out it's the vertices, the vertices for the parabola. Excuse me. Okay, so for the parabola, so this one is any stretching or shrinking. So there's no stretching and shrinking for this. It's just like a normal parabola. And the reason why there's no stretching and shrinking, because at the value of a, it's 1. It's just a normal curve. And that's it. So this one is the final graph of the cosecant function. 1/3 plus cosecant of 3x minus pi over 2. So thank you for watching the video. So once again, rewatch anything, any detail, so things that you were missing during the lecture time. Okay, so I'll see you guys next time. Take care.